Hey everyone, so today what we're going to do is focus on zeros and end behavior. So what we're going to start doing is analyzing, excuse me, graphs of polynomials. So the idea of is like, remember with linear, so x to the first would be a line, right? And then we did a lot last year with quadratics, which was x squared, and we had that parabola. So now we're going to discover if we had any exponent, do we know what it might look like? And it's not exact. We're going to mess around with that, but this is going to be different qualities that what we can get by just looking at the polynomial. So let's talk about end behavior. It's exactly what it says. It's at the end. What is going on at the end of the polynomial? Of course, we know that a polynomial is going to go on forever, but in what direction, right? So first of all, the way we mostly see end behavior is what we call limit notation. So LIM, limit, as x approaches negative infinity, or this one says limit as x approaches infinity. We can think of it more as, hey, if we want to find what's happening on the left side of the graph, this is the notation. If we're saying what's happening on the right side, this is the notation because x is going to infinity, right? X is that horizontal. So when we respond to those questions, what we're actually asking ourselves is, since we know x is going to negative infinity, where is y going? Is y going up to infinity, down to negative infinity, or in some cases in the future, constant? Does it go towards a number? Okay. Now, some of your practice goes back and forth between limit notation, but if we don't use limit notation, this is exactly what you're going to see. So it's kind of like the same thing, just without the LIM, right? As x approaches negative infinity, where does that y value go? As x approaches infinity, where does that y value go? So here are some a chart to help you analyze some things, okay? So first of all, when we are talking about n, we are talking about the exponent. And specifically, we are talking about the largest. So I'm hoping you guys are all good with even and odd numbers, right? Because if it's odd number, what happens is our ends go in different directions. Now, what indicates that the left side goes down, the right side goes up, or the left side goes up, the right side goes down? Well, that's all based on your leading coefficient. Okay, so right there, leading coefficient is a subset n. So we're really looking at that leading term. If that coefficient is positive, I know that the left side of the polynomial will go down to negative infinity and the right side will go up to infinity. So see, this would be our question. This would be our answer. Same thing over here. If the coefficient is negative, then all of a sudden our left side is up and our right side is down. Now, usually what I will do in class, if I'm checking with you, I will actually make you use your hands. The reason why I'm not showing you the hand movement right now, or I wasn't before, is because usually when I record like this, it shows opposite. So the way I want you to do it kind of shows the opposite of what you're doing. So when you see that the exponent, the largest exponent, is an odd value, right away, I want you to start with your left hand down, your right hand up. So we're going to do a little dance, right? Then we look at the leading coefficient. If it's positive, we keep it the same. If it's negative, we flip it. Okay. Now, again, it might look the opposite to you right now because I'm recording. Now, if the largest exponent is even, what happens? Well, we know from a quadratic, x squared, either both of the ends are going to go up or both the ends are going to go down. So when you see that the largest exponent is even, I want you to put your hands up like a goalpost. And then if that leading coefficient is positive, we keep it the same. If it's negative, we flip it. So this is just about the outside, the ends of it. We could have a polynomial that does a bunch of curves in here. We can connect it right away. We don't know what's going on in the middle. It's all about the ends. All right, let's go on to the next page. All right, so what we're going to do is without graphing, we're going to check on these examples right here. Okay. All right, so f of x equals negative x cubed plus 6x squared minus x to the first plus 7. First of all, I want to make sure that it is in standard form. Remember, that's in order from largest to smallest exponent. And it is, because when I do, I'm going to look at that leading term. So if I see right now the exponent or degree, right? In this case is a 3, and a 3 is odd. Okay, remember odd tells us they go in different directions. Now our leading coefficient is negative, right? -1. So that means I think of it as a flip, right? Okay, so those are general things that we can talk about, but we want to put it in the correct form. So limit as x approaches, and it's better just to go from left to right, just like how we read. So on the left side, where would it be going? Okay, remember, odd is opposite, and then we flip it. So originally, my odd means that it goes down and then up here, right? But because we're going to flip it, that means we go up and down. And if you can check, you can always refer back to this chart and say, oh, odd is on the first row here and negative is here. So that's what it's supposed to look like. That gets you used to notation and stuff like that. So that means on the left side, we're going up. So I think of this, I say to myself, we're going up. Well, where does up mean? Up means infinity. Now let's do the right side. So limit as x approaches infinity. Again, if I see my new graph right here, the right side is going down. And what does down usually mean? It means negative infinity. So on your answers, if you were doing this on your homework, you would write down either one of these, but make sure it connects with the left or right side. All right, let's go to the next one. F of x equals 2x to the fourth plus 6x plus 7. Okay, well, let's look at this. Is it in standard form? Yes, it is. So I look at the leading term. Our degree is 4. 4 is what kind of number? It is even. So that means it's both going up or both going down. And then the leading coefficient is a +2. So we keep it the same, which means up. Remember, because I said start up and then only flip if that leading coefficient's a negative. So when we write this now, the left side as x approaches negative infinity, well, what does it face? It faces up, and up goes to infinity. Limit as x approaches infinity, which again is the right side. So if you had to make notes to yourself left or right, go for it. And then the right side is also going up, and we said up is infinity. All right. Let's look at C now. F of x equals negative 32x to the 11th plus 23x to the 25th minus 389x to the 32nd plus 298x squared minus 675. What's wrong? It's not in standard form. If we were in a standard form, we would have to start with the largest exponent. Which one has the largest exponent? Right here, that 32, right? So that coefficient in front is our new leading coefficient. So this is what I'm looking at, not this one. It has to be in standard form. If you don't want to write it in standard form, don't do it. Just circle it like I did. So the degree we're looking at is 32, which is an even number. So we start up that they're both going the same way, right? But the leading coefficient here is negative 389. Well, negative tells us to flip it. So if we flip it, it is now going down. So let's write our limit notation. Limit as x approaches negative infinity, which is the left side. The left side is going down. Down means negative infinity. Limit as x approaches infinity. Right side is going down, and down means negative infinity. Okay, that was end behavior. Now let's go to zeros. All right, actually, why don't we do this? Pause right now. I want you to do the first 2 questions on your 4 questions. Okay, pause right now. Double check with me. All right, hopefully you've checked with me and had that end behavior down. Now let's look at zeros. Zeros can also be known as solutions, roots, and also known as x-intercepts. So all of these are interchangeable. Of course, when we're looking for x-intercepts, we want a coordinate pair, right? Something, comma, something. X-intercept specifically is the number, comma, 0. But if we're looking for zeros or solutions, you just have to say x equals. Okay, we'll get more technical with that later. So the fundamental theorem of algebra says a polynomial function of degree n is greater than 0 has n complex zeros, and some zeros may be repeated. So what we can do, remember, like end behavior shows us the end of the graph. We don't have nothing, we don't know anything that's going in between. Okay, so the same thing when we're looking for zeros. We have an interpretation of them to a certain point. So what we're going to do right now is in example 2a and b, we're going to talk about the largest number of possible zeros. Not to say that this is exactly it, because they can repeat. We're going to discover some of that stuff later, or it can be less than that. How do you find that out? Well, that's pretty simple. The largest exponent, the degree of the polynomial, is the largest, the largest amount of zeros that you can have. Okay, so determine the number of possible. I really want you to keep that in mind. Possible. Okay, it is the largest degree. So if we look at A right here, we have f of x equals 3x cubed plus 2x squared minus 7x plus 2. Is it in standard form? Yes, it is. So since the degree, the highest exponent is 3, that means there are 3 possible zeros. Do we know exactly what they are right now? No, we don't. but we know there's at max 3, which means at max it touches or crosses the x-axis 3 times. Okay. Now B, f of x equals 100 plus x to the 4th minus 29x squared. Did this again on purpose because not all the polynomials are given to you in standard form. So if they are not, you have to make sure you're looking at the leading term in standard form, which would be the highest exponent. So that would be our leading term. Again, write it out if you need to. So that means the degree of this polynomial is 4, which means there are 4 possible zeros. Today, we are going to do some discovery with our calculator. Okay, so get out your calculators. I'm going to show you how to graph if you don't already. I want to make sure my window is at just a normal. Okay. Now, the thing is about these examples here, we're going to use technology today to discover. Next class, we won't. So let's try to pick some things up. These two are actually the same function. They're just in different forms, right? So this is in standard form and this is in factored form. So we factored for you. I'm going to prove to you that they're the same graph. Okay. Sorry, I'm covering up the function. I'm just trying to get out of the light for the camera. Okay, x squared minus x minus 20. So I go to y equals, let me clear out my graphs. It was x, so x is right here, squared minus x, is it minus 20? Yeah, minus 20. Now I'm going to show you these are the same graph. So just by graphing this one right here, this is what I get. Okay. Now, if I go back to y equals and I go to y2, I'm going to put in that factored form, which was x, don't forget parentheses, minus 5, parenthesis, x plus 4. Okay, now I'm going to graph again. And if you look, it's right on top of it because it's the same function. Okay, now, as you can see right here in this graph, it's kind of hard to see, but I want you to look at the zeros, the y-intercept, and the end behavior. Okay, so first of all, let's do a little analyzation before we get to this calculator. If we talk about this degree, what is the highest exponent? The highest exponent is 2, which means there are 2 possible zeros. And it's even. The leading coefficient, as you can see, is 1. So that means our end behavior is the same and they're both up. Okay, so some things I want to prove to you or write down. So let's get that limit, that end behavior down. So the left side, right, should be going up, and that's to infinity. The right side is up, so that's to infinity. We have 2 possible zeros, and we need to find the y-intercept. So I'm going to show you on the calculator how to do this, but then we're going to talk about how we could have done it without the calculator. Let's talk about zeros. Zeros are where it crosses the x-axis, right? So if you look right here, where is our graph crossing? Well, as you can see here, this left side here is crossing at x equals -4. What about the right side? The right side crosses at x equals 5. Now, is there a way that we could have answered this without looking at the graph? What if we just looked at one of these? If you see, we could have done either one of these from the factored form, right? Because It's actually x-intercepts are when y equals 0. So it's almost saying 0 equals x minus 5, x plus 4. And that means we can set both of those pieces together and solve. And that is how we get our zeros. So if we can factor, we don't need the calculator to give us our zeros. Okay. Now, y-intercept. Y-intercept is where it crosses the y-axis. I'm going to move this around. You'll practice this throughout the year. The way I want to see this is I know my end behavior should go up like this. So I know it should dip down here and cross down here. How do I change that? How do I see it? Well, if I go to Windows, I want to lower my y value. Okay, I'm going to lower it to -25. So now I see that dip. Now, yes, visually, this is kind of like, hey, I know it's down here. But how could I do that without looking at the calculator? Well, the y-intercept, of course, is a coordinate pair. And it is when x equals 0. So without a calculator, what we could do is just plug in 0 for x and solve. Now, both of these should come out to say the same. So 0 squared minus 0 minus 20 is -20. If I plug in 0 here, I would get -5 times 4. Well, what's -5 times 4? -20. So again, to find the y-intercept, plug in 0 for x. Okay. Right here, guys, we're not going to keep doing this over and over. So let's do number, that's a tricky one. Let's do, let's just do B right now. I'm hoping that your practice work doesn't overextend. The reason why I don't want to do C, even though it should be fine, is right here. Remember when we factored the other day, we talked about difference of squares. It's because this isn't factored all the way. So this would be x minus 3 times x plus 3. Okay. But if we get to a problem like that on the homework, just raise your hand and we can have that private discussion. Okay. Next class, we're going to get into this a lot. Okay. But I don't want to overwhelm you right now. So let's see. Here we go. We got to do end behavior first, right? So as we approach the left side and as we approach the right side. All right, what is our highest degree in B here? Well, our degree is 3, so that means at most 3 zeros. It's an odd number, so we know it starts with the left side down, right side up. Now, because the leading coefficient is -1, that means we flip. So that left side becomes up, right side is down. Okay, left side is going up and up goes to infinity. Left side is down, down goes to -infinity. Let's do our zeros. Remember when it's factored, which is nice because we have it right there. It's almost as if we just set each of these equal to 0, right? We can also graph it again. So you can see on here, you can practice negative. Don't forget, when you guys graph here, make sure that's a negative and not a subtraction. Otherwise, it won't graph it. X minus 3, x plus 2, x minus 1. I'm going to set my window back to -10. There we go. And where is it crossing? It's crossing at x equals -2, x equals 1, and x equals 3. You guys see that? -2, 1, and 3. And if you look back at our factored form, the -2 is coming from right here, because what makes that 0, hence why it's called 0, 1, and 3. Okay, remember how to find that y-intercept? Again, this graph's a little bit easier that we can look at our calculator and count. But remember what we did last time with the y-intercept? We plug in 0 for the x value. So I like doing the top function. The bottom function is still the same. So either way is fine. 0 plus 0 plus 0 minus 6 is -6. And you're done. By the way, down here at the end of your notes, it says to find 0. So if you wanted to know the exact 0 on your calculator, especially if you weren't given factored form, for us to visually see that, what you can do is you go to second trace, go down to 0, enter, and then see how I have that flashy dot. I'm going to go to one of my zeros, so I'm going to go to this 0. Now here's the trick. You see down here how it says left bound? I need to make sure I'm on the left side of that intersection, okay? So I'm going to go on the left side there, press enter, go to the right, make sure that I'm not quite on that spot, and then press enter 2 more times, and it gives you that 0 of -2. This is something we'll get used to throughout the year, so don't worry if it's not a big thing right now, because if you have it in factored form, we can just set each part equal to 0. For those of you who have questions like this, okay, and you're trying to find the 0, okay. Of course, yes, this one's easy to see, right? The 0 here is 1, right? What makes that 0? But if you have something like this, make sure on the side that you are setting that equal to 0 and solving. So 2x equals -1, x equals -1/2. Don't just look at that second term there. You have to solve. Okay, let's get a little bit of practice with that. Do 3 and 4 for me on your check sheet, and then check in with me.